Hi friends, again welcome to Incredible Learning Experience JNANA Learning. Continuing with the lecture on digital signal processing, and today's topic is designing of IIR filters. So in previous lecture we discussed about the digital filters used in DSP. That two types of digital filters are used in digital signal processing, that is IIR filter and FIR filter. And in this lecture we are discussing the designing techniques of an IIR filter, that is infinite impulse response filter. So the most common technique used for designing IIR digital filters are known as indirect method, which involves first designing an analog prototype filter and then transforming that particular prototype to a digital filter. That's why it is called as indirect method. That is, we are not directly designing an IIR digital filter. First we design an analog prototype filter for a particular specification. Then we transform that particular prototype into the digital filter. Now for a given specification, the transfer function of digital filter can be derived using three steps. That is, step number 1, first we have to map the required digital filter specification into those for an equivalent analog filter for the analog prototype. Then step number 2, derive the analog transfer function for analog prototype. Then step number 3, transform the analog prototype transfer function into an equivalent digital filter transfer function. So these are the three steps through which we will derive the transfer function for the required digital filter. So first of all we will discuss the designing of the analog filter. So from the given specification, first we will design an analog prototype filter, especially an analog low pass filter. Then if the requirement is for a high pass filter, band pass filter or bandstop filter, it is transformed from this analog low pass filter to the required filter. The two techniques or the design methods for the analog filter design, analog low pass filter design, are Butterworth filter and Chebyshev filter. So these are the two types of analog filter design, that is Butterworth filter design and Chebyshev filter design. So by using the Butterworth filter design or Chebyshev filter design, we will find out the transfer function, analog filter transfer function for a normalized low pass filter. Then if the requirement is for a high pass filter, band pass filter or bandstop filter or a low pass filter with different cutoff frequency, we will go for the transformation, and it is given over here. That is, first one, it is the transformation from low pass to low pass, which means that we are designing the filter, analog filter, for a normalized low pass filter using the Butterworth filter design or Chebyshev filter design. So it is desirable to have a low pass filter with a different cutoff frequency. So omega c, it is the cutoff frequency. So for transforming the normalized low pass filter to another low pass filter with cutoff frequency, the transformation is given as S is transformed to S by omega c, which is the cutoff frequency. Now if we need to transform from low pass to high pass, that is a normalized low pass filter to a high pass filter, then the transformation is given as S is transformed to omega c by S, that is omega c the cutoff frequency by S. And the third case, that is low pass to band pass, then the transformation is S is transformed to S square plus omega L omega u by S into omega u minus omega L, where omega L and omega u are the lower cutoff frequency and upper cutoff frequency. Omega L stands for lower cutoff frequency and omega u stands for upper cutoff frequency. And The fourth one, that is, if we want to transform the normalized low pass filter design to a band pass filter design, then the transformation is S is transformed to S into omega u minus omega L by S square plus omega L omega u. Again here omega u, it is the upper cutoff frequency, and omega L, it is the lower cutoff frequency. So this is how we design or find out the transfer function, analog filter transfer function. Next we move on to the important step in designing IIR filter, that is design of IIR filter from analog filter. So there are several methods that can be used to design the digital filter having an infinite duration, unit sample response. And whatever techniques we used, all are based on converting an analog filter into a digital filter. So the analog filter is better described using the S plane and the digital filter using the Z plane. So here shows that transformation from S plane to Z plane, that is transformation from analog filter to digital filter. The S plane means the sigma j omega axis, and Z plane have real part of Z and imaginary part of Z, and here shown a unit circle. Now it is said that if the conversion from analog filter to digital filter or from analog domain to digital domain is to be effective, it should possess some desirable properties. That is, first one is that the j omega axis in the S plane should map into the unit circle in Z plane. That is, j omega axis in this S plane should map into the unit circle in the Z plane. Thus, there will be a direct relationship between the two frequency variables in two domains, that is analog domain and digital domain. Now, the left half plane of the S plane, that is this region, the left half plane of the S plane should map into the inside of the unit circle in Z plane. That is shown here, that is the left half plane of the S plane should map into the inside of the unit circle in the Z plane. So this shaded region, it is the unit circle. Thus a stable analog filter will be converted to a stable digital filter. That is, a stable analog filter will be converted to a stable digital filter. So that particular mapping and transformation is explained using the S plane and Z plane image over here. So this is the transformation actually we are doing, and there are several methods for this particular transformation. So here are the methods for digitizing the analog filter. First one, bilinear transformation. Second one, approximation of derivatives. Then impulse invariant transformation and matched set transform technique. So these are the techniques by which we digitize that particular analog filter into the digital filter. Among this, bilinear transformation is the most important technique for transforming analog filter to digital filter. This we will discuss in the upcoming lecture. So these are the techniques used for digitizing the analog filter. So once we have transformed the analog filter into digital filter, now we have the filter in digital domain. And in digital domain also there is a portion for transformation, that is from low pass to low pass, low pass to high pass, low pass to band pass, and low pass to band stop. So we will discuss that also. So first one, that is low pass to low pass transformation. So as it is a digital domain, here the transformation is as follows, that is Z inverse is transformed to Z inverse minus alpha by 1 minus alpha Z inverse, where alpha, which is equal to sine omega p minus omega p dash by 2 divided by sine omega p plus omega p dash by 2, where omega p is the passband frequency of low pass filter and omega p dash is the passband frequency of new low pass filter. So in analog domain we have seen the transformation using S. So as here it is a digital domain, the transformation is using Z inverse. The second one, that is the transformation from low pass to high pass. Here the transformation is Z inverse is equal to minus Z inverse plus alpha by 1 plus alpha Z inverse, where alpha is equal to minus cos omega p dash plus omega p by 2 by cos omega p dash minus omega p by 2, where omega p, which is the passband frequency of low pass filter, and omega p dash, which is the passband frequency of high pass filter. Next one, which is the transformation from low pass to band pass. Here the transformation is Z inverse is minus Z raised to minus 2 alpha k by 1 plus k Z raised to minus 1 plus k minus 1 by k plus 1, and in denominator k minus 1 by k plus 1 Z raised to minus 2 alpha k by k plus 1 Z raised to minus 1 plus 1. Here alpha, which is equal to cos omega u plus omega L by 2 divided by cos omega u minus omega L by 2, where k, which is equal to cot omega u minus omega L by 2 tan omega p by 2. Here omega u, which is the upper cutoff frequency, and omega L, which is the lower cutoff frequency. And finally, the transformation from low pass to band stop. Here Z inverse is transformed into Z raised to minus 2 alpha by 1 plus k Z raised to minus 1 plus 1 minus k by 1 plus k. In the denominator 1 minus k by 1 plus k Z raised to minus 2 alpha by 1 plus k Z raised to minus 1 plus 1, where alpha is equal to cos omega u plus omega L by 2 divided by cos omega u minus omega L by 2, where k is equal to tan omega u minus omega L by 2 tan omega p by 2. So these are the transformation in digital domain. So hope you have got an idea how to design an IIR filter. So in the next lecture we will discuss the design of IIR filter with some examples. So keep watching and subscribe our channel JNANA Learning. Thank you so much.